Now that we've learned about combinations, I'd like to return one more time to the sections of a circle problem that we've talked about earlier in the course. So where we left off in the last video, if you watched that one, was that we had talked about the number of sections in the circle, and we had built this up starting with the initial first section that you get if you just have a single point or 0 points, and then we made the observation that every time you draw a simple line in this circle, one that does not cross any others, like from here to here, what that does is it adds another section to the circle. So we said that the number of sections of the circle would be at least that first one plus the number of lines that we add. And then we also noticed that we get even more sections when these lines cross other lines. So when you put in a line that crosses others, it adds one section for just putting in the line, but then it also adds a section every time it crosses another line. So what that turns out to equal is the number of 1 plus the number of lines, and then we said that that's also plus the number of interior intersections. So every time we have two lines intersecting at a point, that represents a time when another section was added to the circle. So from there, we haven't quite yet been able to develop this formula. We know what it is. We've talked about this. This represents the maximum number of sections in a circle with endpoints, where we've connected all of those points with chords in the circle. But what we need to do now is make the jump from this discussion to that formula. And this is where we need combinations. So here's the interesting part. If you look at the number of lines, it turns out that we can just talk about a line as a combination of 2 points. Or in other words, every time we have a line, it's just physically illustrating like a connection between those 2 points. All right, so let's test this out in a few small cases. So let's say that I have 3 points here, and I've connected them all with lines. All right, so we can clearly count this one. We've got 3 lines there. And then notice if you think of the number of lines now as combinations, this would really be asking, well, how many ways are there to combine 2 out of those 3 points and combine them by drawing a line between them? All right, so if we make the calculation 3 combine 2, or 3 combinations 2, okay, then we can use a calculator to figure that out, or whatever method you like, and that actually does equal, that actually does equal 3. Let's try it out for another case. So let me put a 4th point on here and then draw in all possible lines. Okay, so counting, we have that the number of lines is 6. So if we compare that to the combinations, well, what's 4 points? Choose 2. Look at combinations of 2 of those, and that also turns out to be 6. All right, so we can kind of see that comparison there. All right, so if we looked at our circle again and we draw, end points, well, then the number of lines that we could make, and we want the maximum number of lines if we're going to get the maximum number of sections, well, the number of lines that we could make would just be n choose 2. We want to know how many ways are there to combine 2 out of those endpoints. Okay, so now let's look at the number of interior intersections. Now the observation here is just that if you choose any intersection, notice that it takes 2 lines to make an intersection, and each of those lines consists of 2 different points. Right? So if we wanted to count the maximum number of sections in the circle, we would want the maximum number of intersections possible. So I want to shove these points around, move them back and forth around the circle so that I get as many intersections as possible. All right, so what I'm asking is, how many ways are there to make all of those intersections? Right? And if I think of an intersection as a combination of 4 different points, then we can actually make that calculation. So let's test this in a couple small cases again. If I go back to the case where we had, if we had 3 points, Okay, at least the way I've drawn the points here, it doesn't seem like there are any intersections, all right? But is this the maximum number of intersections from 3 points? So I'm not sure about that. So if we check it, you know, how many ways are there to choose 4 points? Well, in this case, we don't have 4 points, so that explains it. Like if we had, say we could get an intersection somewhere in here, that would mean that I had 2 different lines going through that point to make the intersection, and I'd have to follow those out to even, you know, to even get 2 lines, I'd have to have at least 4 different points. Okay, so there are no intersections with just 3 points. Now when we add in the 4th point, as we had before, and draw in the lines, now it seems like we can get internal intersections. Okay, and it looks like I just have 1, but is that the maximum number I can get? Well, let's calculate it. So we want to know if we have 4 points, how many ways are there to choose 4 of them? Because every one of those choices would represent a unique intersection. All right, well, 4 choose 4 is just 1. All right, so there's no way that I can move these points around the circle, you know, sliding them back and forth, so that I could get any more intersections than that. All right, now if we had n points, then the number of intersections would just be n choose 4. Right, I would want to know how many ways can I take 4 of those points and connect them, making like diagonals like this, so that I get an intersection. All right, so if we return to the equation here, almost an equation, an expression so far, for the maximum number of sections in a circle, now I can rewrite this. It's 1, the initial large circle section, plus the number of lines, which is n choose 2, plus the number of intersections, which is n choose 4. And then once we have that, it's just a matter of algebra to get to the equation. So here's where we would like to end up, and let's actually go through the math to see if we can get this. And at any point, if you want to pause the video and try this on your own, it can be kind of fun to see for yourself if you're able to get this. So if you're comfortable with factorials and factoring and working with variable expressions, go for it. Now's your chance. All right, so let's do the math. So we have n choose 2, n choose 4. Okay, so we need, first of all, we need the formula for factorials, or for combinations. Right, so we know combinations, n choose r would be n factorial over n minus r factorial, r factorial. Right? So in this first case, all we're doing is saying that the r is 2, so I'm going to replace, in that expression, replace the r's with 2's. Okay, and then in the second expression, replace the r's with 4's. Okay, next we want to cancel out any common factors in the numerator and denominator. So we've seen a few examples like this before, but if you look at this first expression, this is n times n minus 1 times n minus 2 times n minus 3 and so forth all the way down to 1. And in the denominator we have n minus 2 times n minus 3 and so forth all the way down to 1. And then we also have times 2 times 1. Okay, so everything from n minus 2 all the way down to 1 cancels in the numerator and denominator, and that leaves us with n times n minus 1 over 2. Okay, so that part, and let's distribute. So n times n minus 1 becomes n squared minus n, and then the denominator we've got 2. And then let's do the same thing for n choose 4. So here we would have in the numerator n times n minus 1, n minus 2, n minus 3, n minus 4, and it keeps going, so I'm going to just write factorial. So that would go down to n minus 5, n minus 6, all the way down to 1. And then the denominator also has n minus 4 factorial, and then 4 factorial. Okay. So everything from n minus 4 down to 1, all of those factors cancel, and then this leaves us with 4 different terms in the numerator, or 4 expressions to multiply, and then we've got 4 factorial in the denominator. Alright, so next we have some multiplying to do in the numerator. So let's do this part, and we'll multiply 2 at a time. Okay, so first we have n times n minus 1, and we've already done that. That's n squared minus n. Okay. The second part, n minus 2 times n minus 3. All right, if you remember FOIL, we could use that to multiply. So we're distributing each of the first 2 terms, the n and the negative 2, to the n and the negative 3 in the second 2. All right, so using FOIL, that would be n squared, okay, n times n. Then the outer terms, we've got negative 3 times n, inner terms negative 2 times n, and last terms negative 2 times negative 3 is positive 6. Okay. Combine like terms there, so that would be n squared minus 5n plus 6. Okay. And I'm ignoring the denominator for now, but I know 4 factorial is going to be 24. But we are still working on the numerator. So we have one more multiplication to do, and we can use the distributive property here. So we're going to do n squared times each of the terms in the second parentheses. So we would have n squared times n squared is n to the 4th. Then n squared times negative 5n is negative 5n cubed. And then n squared times 6 is plus 6n squared. And then we go back and do this negative n and distribute that. So we would have negative n times n squared is negative n cubed, and then negative n times negative 5n is positive 5n squared, and then finally negative n times 6 would be negative 6n. And again, combining like terms, we've got n to the 4th, okay, and then negative 5n cubed plus negative 1n cubed is negative 6n cubed. Okay, and then we've got 2n squared terms. We've got 6n squared and 5n squared, so that's 11n squared. And then finally negative 6n. So that is all in the numerator, and that's all over 24. Okay, so we are almost to the formula. There's one more thing we would want to do here, and that's to combine these 3 things that are being added into one big fraction. So to do that, we want to get a common denominator. So right now the denominators are 1, 2, and 24. So the least common denominator of those 3 would be 24. So I'm going to multiply this first fraction 1 by 24 over 24. And I'll multiply the second one by 12 over 12. And then the third one already has the denominator that we want. So that's going to be 24 over 24 plus, and then the 12 needs to be distributed. So this would be 12n squared minus 12n, and that's over 24, and then plus all of this stuff. Okay, so combining into one big fraction, and I think I'll add like terms while I'm at it too. Okay, so all of the numerators will get added. So let me look through. I have an n to the 4th, and then let's look for n cubed. So I have negative 6n cubed, that's the only one. And then n squareds. I've got 11n squared and 12n squared, so that's 23n squared. And then n's, we've got negative 12n and negative 6n, negative 18n. And then finally this 24, plus 24. And that's all over the denominator 24. So let's check it, and here it is. This is the formula that we had in the very beginning. Okay. So isn't that neat? So all we really needed to develop this, we needed to know combinations and then some basic algebra rules like multiplying and adding, working with variable expressions. But that's it, and that's how we would develop that formula for the maximum number of sections in a circle. And okay, that's it.